This is VCube here. In this video, we'll be solving a question which uses triangle inequality. So I'm kind of planning to solve this question in two different methods. One is a trial and error method, and second one is by solving the inequality. So let's get started with the problem. So they have given us three sides of the triangle, which are 5, 5 and 5 r square. So in order to know the triangle inequality, uh, let me write, let A, B, C be the sides of the triangle. So your triangle inequality states that your sum of two sides has to be greater than the third side. So B plus C should be greater than A, and then your C plus B should be, your C plus A should be greater than B. So this is your triangle inequality, right? So what I'm now going to do is, so when it comes to equality, let's say that x plus y is greater than z. It is as same as writing 5x plus 5y is greater than 5z, right? So instead of considering 5, 5r and 5r square, it is enough to check for 1r and then r square. So what I'm going to do is, let me write it in tabular form. So 1r and r square. So suppose if r is equal to 5 by 4, 1 will remain as 1 and r will be 5 by 4 and r square will be 25 by 16. So I can multiply and divide it by 4 in order to make it denominator 16, and here also what I can do is I can write 16 by 16. See, when we look at this inequality, we are having three conditions, right? So we can actually reduce it to 1 if we know the greatest side. See, obviously, for example, your third side is the greatest side. Your third side plus your first side will be obviously greater than your second side, and so on and so forth. So it is just enough if we know that the largest side of the triangle, we can simply add the shortest side. So example, if C is the largest side, and if I add the two smaller sides of the triangle, and if it is greater than the third side of the triangle, then the other three conditions also automatically satisfies, right? So that is what I'm going to do over here. What I'm going to do is I'm going to pick the largest one. So here the largest one is 25 by 16, and what I'm going to do is I'm going to add the two smaller sides, so which is 20 plus 16 upon 16, which is going to be 36 by 16, and it is greater than 25 by 16. So your triangle inequality is solved, right? So it is enough to simply just check if the sum of the two smaller sides are greater than the larger side, right? So now let me also check it for r equals 7 by 4. When r equals 7 by 4, you will be having 1 to be 1 and r to be 7 by 4 and r squared to be 49 by 16. And now again I can multiply and divide it by 4, and here I can do it by 16. I'll be having 16 by 16 plus 28 by 16. We are going to check if it is greater than 49 by 16. So 28 plus 16 is going to give me 38, 44 by 16. So 44 by 16, is it greater than 49 by 16? No, right? So here your inequalities condition is not satisfied. So what I'm going to do is, we are going to simply say that r cannot be equal to 7 by 4, and that is the answer for this particular question. It is easy. So now if you are going to generalize this question, instead of using trial and error is the easy method for this problem, but if you want to need an or say a general solution, what we are going to do is, we are going to consider, again I'm going to consider 1 r and then r square. All right. So whenever r is greater than 1, among these three, the maximum of 1r and r square would be r square obviously, right? So what I can do is the condition would be sum of two smaller sides should be greater than the larger side is the condition now. The reason why I've taken r to be greater than 1 is if r is less than 1 then r square would go even smaller. So it is very important to mention that r is greater than 1. So let's get started with the problem. What I'm going to do is I'm going to subtract minus 1 on both sides and then subtract r on both sides. So I'll be getting 0 greater than r square minus r and then minus 1. Now what I'm going to do is I'm going to flip the inequality. The reason why I'm going to flip the inequality is that I'm going to interchange your left hand side with the right hand side. So r square minus r minus 1 and 0 goes over here. So your greater than becomes now less than. So now we are going to solve the inequality. The inequality is pretty much not easily solvable. So what I'm going to do is I'm going to use the quadratic formula. So which is x is equal to minus b plus or minus root over b square minus 4 into a into c divided by 2a. So I'll be getting 1 plus or minus root over 1 plus 4 divided by 2. So it should be 1 plus or minus root over 5 by 2 is the answer over here. Now what I can do is I can simply draw a number line which runs from minus infinity to plus infinity and I can locate these 2 points. So my first point would go over here, which is 1 plus root 5 by 2, and my second point would go over here, 1 minus root 5 over 2, and in between I'll be having the 0. So that is your hint. So here we are having 3 intervals. So this I can label it as your first interval, and this one to be your second interval, and this one to be your third interval. Now our problem is to solve for the intervals such that only one, or it is not only one, it can be more than one also. So what are the intervals that are solving the above inequality is what we are going to solve now. So let me write my first interval, my second interval and my third interval. So we are going to examine the sign for r square minus r minus 1. So in order to examine it, we can simply take a sample point. So let me examine I2 first. Since I2 has 0, the value is going to be minus 0 square minus 0 minus 1, which is going to be negative ultimately. And for I1, probably I can take a random, x equals minus 10. I can take negative 10. So this one would be 100. Minus of minus 10 would become plus 10 minus 1. So it is obviously positive. And here if we take x is equal to plus 10, again it is going to be a positive value, right? For what values of r, the inequality is less than 0. Less than 0 implies negative. So only for your second interval. So the solution set is minus 1 minus root 5 by 2 comma 1 plus root 5 by 2. Now we can again examine the options. So let me write the options over here. So option A is 5 by 4, option B is 7 by 4, option C is 3 by 2, and my option D is 3 by 4. So obviously I cannot examine for 3 by 4 because 3 by 4 is less than 1. So I can only check for the other 3, because only in the other 3 options you are having your numerator to be greater than your denominator. So the value is going to be greater than 1, right? So yes, so in order to do this, let me first write what is 5 by 4 is. So 5 by 4's answer would be 1.25, and 7 by 4's answer would be 1.75, and 3 by 2's answer would be 1.5. Now your root 5 answer is, so let me also find 1 minus root 5 by 2, which is going to be minus 0.618 and 1.618. So the range of this interval is minus 0.618 to 1.618. So whenever r is greater than 1, obviously 1.5 is fitting inside the inequality, and then 1.25 also, it is the 1.75 which is not inside. So your answer again would be B, which is 1.75, because this particular question has only one solution. So you can directly go away straight out and select B. So if it has more than one solution, then again I'll have to check it for 3 by 4. Probably for 3 by 4 you can use a trial and error method, right? So yes. So this is how you solve the question. Please subscribe us for more such content. Thank you.